As you already noticed last time, we are in the kind of philosophical part of the course, no equations and easy on the mathematical side. But still, one has to invest energy, intellectual energy into these issues as well, the philosophical part. As I said last time, I want to emphasize that in this part, first of all, I have to choose that there are many views on every word and many papers and sometimes books, but I have to choose according to my own personal preference and also to what I think are the most important opinions on these issues. But some aspect, some of the conclusions I think I hold very strongly, and I'm willing to debate vigorously, even if I'm turn out to be wrong. Others are tentative. I have my preference, but I cannot defend them strongly. Okay, so this is invitation for discussion. It's not math, it's not science, it's thinking, it's thought. Okay, so please accept my invitation. Stop me, ask, argue. Okay, so I ended last week the survey of what reduction and emergence are in the kind of physical sciences, biology, chemistry, I'm sorry, physics, chemistry, biology, and so on. And I want now to discuss the question about mental to physical. You can say psychology to physics or psychology to neuroscience or whatever, but sometimes it's called also mental to physical. What is the relation? Is mental reducible to neural processes? Is it emergent of neural processes of the brain? Or if not, what are the relations between those two? And again, I don't want to repeat kind of brute force dualism. We started the course by quoting those positions. It's simply, okay, if you believe in it and you accept it, then fine. But if the whole course is trying to build a scientific perspective, so we are kind of committed to some at least weak sense of physicalism. Beyond that, I concluded my analysis of causality in the physical world with the closure principle. Okay, and I'm going to hold to it in the conclusions later on that I'll come. Okay, so why shall we? What is the reason not to put mental to physical or psychology to neuroscience under the same framework as we discuss chemistry to physics or biology to biochemistry and so on? What might be special about the mental? Okay, so what I'm going to do is to discuss the following aspects, the following ingredients. One is there something like mental causation? Intuitively, we have very strong feeling that we wish something and therefore we act upon it and do something and so on. We believe in something and therefore we desire it. So all our internal introspective and our external communication with language, all our thoughts are full with the notion that the mental states and the mental processes, whether they are beliefs or desires or emotions, are causal. If there is something that we believe in, is this causality that we want something, we decide something, we do something, and so on and so forth. So that's the issue of mental causation. Is it, how do we interpret this causation? How do we make sense of this causation? Second question, which is maybe a weaker sense of mental emergent. In other words, whether it's causal or not, but can we say that the mental states and processes are emergent of the brain? Like John Searle says about consciousness. Consciousness is a higher level or emergent property of the brain. Okay, can we defend this position? And finally, the question of consciousness, which brings with it an extra, potentially extra set of questions. Okay, so I'm going to discuss all three of them, all three of these points, and I hope I'll cover them the first part of the lecture, and hopefully after the break, I will be able to start putting everything together in the discussion about free will. But that's, right now, it's not about free will, it's more general, psychology, and so on. Okay, so let's first talk about mental causation. Mental causation, I already, from what I told you in the last lectures, I don't have much favor, or I don't have much sympathy with it in the following sense. If there is a notion of mental causation as kind of autonomous or independent of the physical, that I have a problem with that, because if you hold microphysical causal closure, as we discussed last week, if we hold that causal exclusion, that if there is a physical causal explanation for something, then that's to say that also the mental causes it, doesn't add anything. And finally, so the only possibility is that mental causation, whatever it is reducible to microphysics. Okay, and if you don't hold this, then these three positions are inconsistent with each other. You have to give up. Either you give up on physical closure, there is some mental, new physical force, which is called mental, and it's holistic, and you cannot see it in the lab, etc., etc. Or you can say, well, there are two things which cause the same event, or that you are saying mental causation, whatever it is good, it is important, it has a lot of explanatory power, but it is in principle reducible to the physics. It's not something above and beyond. Okay. So my conclusion, mental causation, mental causal relations of power reducible in principle to microphysical laws. It doesn't mean that it's practical or it's easy to derive mental causal relations from physics or from biochemistry or from genetics, etc., etc. But in principle, this is the picture. Okay, at least my view is that this is kind of a clear-cut conclusion. Okay. However, we can say it also in chemistry, but chemistry is a very important science. We can say it on other parts of biology, not biology in general, not mental. You can also say, but it doesn't mean that biology is not a very powerful science. Okay, so can we say the same about the mental? Okay, so psychology is a science, very rich, very important, although in principle, it doesn't have independent causal powers beyond physics. So I'm going now to spend some time in discussing an argument, a very famous and important argument in philosophy of science and philosophy of mind, that claim that there is something special about mental state and processes which make them not even in principle reducible to physics or to the brain or to neural processes. Okay, which is different from chemistry and maybe other aspects of biology, but definitely different from chemistry and physics and so on. Okay, so what are these? What is potential uniqueness in the mental? So the argument, at least one important part of the argument, is called, okay, so before that, we already talked about mathematics, language, symbolic system, legal system. The question is, what is cognitive or mental systems? Are they, where do they belong? We discussed it last time, so let me move on. So the problem is, or at least one important part or one problem that is raised against reduction of the mental to physical, against reduction of psychology to neuroscience, is the problem of multiple realizability. So let me remind you, we discussed briefly multiple realizability in a few lectures back. And the idea is that when you look in general at macro states and macro processes, even in physics, then you have under the same macroscopic properties are shared by enormous part of the state space of microstates within the same physical system. But more than that, moreover, the same macroscopic properties may be shared by systems, physical systems, which are very different in their structure, in their micro constituents. Okay? So is it a problem? Is it an issue? Does it disconnect the macro from the micro? So I would argue that it's not. It's interesting. It's a very important phenomenon. It is an important part of physics and physical research to explain those enormous universality. It's not trivial. However, it's not also problematic in the sense of, okay, so now the macro lives kind of on its own. Why? Because the same theory that tells us about the universality of macroscopic properties also tells us in physics, at least, the reason why those different systems share the same macro properties. And this can be symmetries, spatial, or symmetries of order parameters, degrees of freedom, dimensionality, 2-dimension, 3-dimension, 1-dimension, type and range of interaction. Sorry, what happened? Type of range of interactions, and a few more properties of the microphysical system that are responsible for uniting them in the same macroscopic system. Okay, so in that sense, it's fine. It is important, but it doesn't bring us some conceptual, metaphysical problem, in my view at least. Okay, so emergent and multiple realizability, universality are all compatible, consistent with the view that the macroscopic laws can be in principle explained or reduced to the microscopic properties, including explanation of the range and limitations of the multiple realizability. Okay, however, is it the same in cognitive systems or in psychology? So one of the philosophers that raised this problem in the multiple realizability in the context of the mind is the famous, well-known philosopher Hilary Putnam, one of the most important influential philosophers of mathematics, science in general, logic and the mind. Very influential philosopher who raised this issue. So the issue that he raised is in the context of a debate at that time already of the relation between mental states and brain processes. One old view is that psychology can view the brain or the mind as a black box and simply ignore it. That's behaviorism. Psychology has to explain stimulus to action relation. Okay, Skinner behaviorism. This is an old position which was discarded because it was weak and not fruitful, because it's clear that organisms, especially complex organisms like mammals, but even lower organisms, show complexity of relation between input and output, stimulus and behavior, which does not fall under the category of reflex or simple mapping. You have to introduce intermediate mental states, beliefs, desires, emotions, etc. So the other extreme was that mental states are identical to brain states. Okay, emotion, okay, fear, or depression, or happiness, and so on, feel of happiness. All these are simply neural states, okay? Now, so Hilary Putnam says this is a problematic. And he takes the famous example of pain, okay? So pain is, the feeling of pain is a well-defined concrete mental state. If you believe in identity of brain and mind, okay, then you must hold that to have pain is to have a specific pattern of neural activity in our language, a specific physical chemical state in the brain, such that whenever you have that state, you have pain, and you don't have pain if you don't have that state. This is kind of the simple-minded relationship between brain and mind. But he said it's impossible. We know, presumably empirically, but maybe even more than that, but let's say empirically, that animals of very different nervous systems also exhibit pain. So how can pain be reduced to a physical, a neural state, a brain state? Moreover, you can imagine that you have, I don't know, agents from, creatures from Mars. They probably come here and also will have pain. Or maybe even robots may have pain. Non-biological entities at all, okay, have pain. But if you go that far, but even if you stay within biology, let's say you take humans and you take a worm, a fish, a worm, C. elegans. All of them, if you assume, have pain or show the mental state of pain, exhibit pain. If it is so, how can you say that pain is reducible to a neural mechanism? Presumably the mechanism that generates pain in my brain is completely different from the mechanism that generates pain in the C. elegans, not to say about robots and so on and so forth. So multiple realization seems to pose a problem to any attempt of reducing mental states to brain states. Okay, So here
Why?
is
I mean, we talked about microsystems and macrosystems, that a macro property like equilibrium can be achieved by different microstates, totally different ecostates. So
yeah, so I'm not talking about, again, so I think last week I made a distinction between dynamic multiple realizability and structural one. And again, philosophers argue about both of them, but I'm willing to set aside the issue of microstates, because you can imagine that I have pain under slightly different patterns of neural activity in my brain. But I would imagine that the mechanism are common within my brain. So there will be an enormous variability in the microstates, but it will be part of the region in my state space of the brain, which correspond to the macrostate brain, macrostate pain. So I don't think this is a big, in my view, big issue, okay? Presumably there will be some common mechanism underlying the generation of pain in my brain, okay, which is relevantly common in all microstates of my brain. So I'm not talking about that. I'm talking about structural multiple realizability. I'm talking about systems that have very different structures in their neural responses. So let's imagine that for me, in my brain, every time there is part of, I don't know, my prefrontal cortex or my amygdala, there's some pattern of activity there, it causes pain in my brain, okay? But now you go to animals that don't have cortex or don't have amygdala, so they won't have pain. But they do presumably show pain also. You poke, just a moment, let me just finish. You poke a worm with some unpleasant stimulus to warm, pressure, and so on. They will freeze, or they will avoid, they'll escape, they'll generate all things that, all kinds of behavioral patterns that we associate with pain, okay? So this is the question, is structurally heterogeneous, not dynamic. Yes.
Haim?
Yes.
So here you assume that how do you perceive pain is exactly like how the C. elegans perceives pain, and it does not have to be. You can simply, like, maybe you just call both behaviors as pain, and then different structures can lead to different pains.
Right, that's part of the argument. So, but for now, let's assume that even though my pain is not identical to the C. elegans pain, but there is sufficient commonality that we justified in calling both of them pain, okay? We'll come to the issue that you're raising, that you raise in a few moments. But let's assume that both of them are justifiably called pain, okay? And we are looking at that common concept of pain, that's kind of universal concept of pain. And we ask, okay, so it's true that my pain is not the same as, exactly the same, but if there is such a thing like pain that unites my pain and the C. elegans pain, the mouse pain, and maybe even beyond biology, then can this concept be reducible to physical mechanisms, given that the physical mechanisms are unlikely to be uniform? That's the question. Okay, I'm not saying I completely buy it, but I'm open this for discussion, and we'll see arguments back and forth. Elisha.
But yeah, that's the thing. Define pain. It's like semantics. You
Can you say it again?
No, it's semantics. Like how you define pain. The thing, like what Shaked said before. So it's like the problem is not.
So let me ask you. You think if you think mouse have pain?
Yes.
So you think animals have pain? You think fish?
Yeah, but there's a lot of types of pain. That's the thing. How would you define it?
No, but I'm asking the way you define it. Tell me what you think.
I define it as, I think there's a difference between pain and nociception, for example.
Between pain and?
Nociception. I mean, I can really define pain. I can define nociception for you, I guess. Pain is too big of a thing.
Nociception is a mechanism.
Yeah, that's the thing. When you say pain,
about the feeling of pain, the mental state of having pain, and what the consequence, you know, I want to avoid it. It's unpleasant, and so on. Do you think a mouse has it or not?
Yeah.
I interrupt, Professor.
Wait, let's finish with that's. I want to hear Elisheva. Do you think? If you don't think, then the argument is closed. If you think, well, pain is a human concept, and I don't know, you may say.
No, I'm not saying it's a human concept. I'm saying it's a too vast of a concept. We're using it's a language problem. We generalize something, let's call it pain, and there are different kinds of pain. So I can talk about mechanistic.
So you say pain is a language, is a word in the language, but it's not. It should be part of psychology.
Yes, I mean there's no clear understanding what we say, what we mean when we say pain. So we can't really argue.
Fine, okay, legitimate. Putnam and many others don't think so, but okay, I hear it. Okay, we'll come to it. Okay.
I just want to point out that, as far as I understand, your definition of pain, how do you define it by the human being and by the worm, is that you poke the worm and it responds and tries to evade it. It's a very behavioralistic definition of pain. It's okay, like if it quacks, it's a duck. So if the worm is getting poked and negative stimulus and tries to evade it, okay. So I'll make a program and my computer says if negative stimulus, then avoid. So my computer program in R has pain now. If it quacks.
So your conclusion is that the worm does not have pain. Or what?
I
what you think.
If the worm has pain and I have pain,
yeah.
To some defined property that both of us have pain. I mean, as far as I understand, you define that the worm and the human being both have pains. And your argumentation, as I heard it, because it evades stimulus, the negative stimulus, and responds to it, tries to evade it, that was your definition of pain.
Yeah.
So the point I wanted to say is, one, your definition of pain is very behavioralistic. If there's a negative stimulus, I'm avoiding it. And I'm extrapolating it. This definition I can apply to my program in MATLAB with 2 lines.
I am not fine, but I'm just asking you. You have a different definition of pain. I heard you. I understand, but I'm asking you. You have a different definition. Let's say desire. Let's say satisfaction, or you know, all the things that psychology is about. I'm asking memory. Learning. I mean, pain is just an example, but we can go on through all the concepts that have the textbooks of psychology, and ask
memory,
whether
I think memory is very simple.
Whether these notions have scientific significance. Okay, Elisheva is right. They are part of the language, and fine. But if they are not, then okay. So let's forget about psychology as a science and say, well, okay, we talk about it and so on. So I don't know. You're saying MATLAB program. I don't know. I'm asking you, a mouse has pain or not? A mouse feels hunger or not? A mouse is thirsty or not?
Pain is different from anger and thirst. It's something else. It's kind of a conscious experience.
So
like, there's no area in the brain for pain, for example. You can't stimulate an area in the brain and causes someone to feel pain. It's something more general. It's something more, I don't know.
So you are saying pain is not about the brain, it's about, that's what you are saying?
No, it's of course it's about the brain. I'm just saying it's more complex. It's a conscious experience. No, it's a conscious experience, so you can't really lock it in one place. It's something.
Okay, we'll come to consciousness. Okay, it's of course conscious experience. Okay, we'll come to it, but
I just want to give the example of
mouse doesn't have conscious experience or what? I don't know. So let's talk about conscious experience. Mice have.
My opinion, yes. I don't know.
What?
In my opinion, yes, but I don't know.
So so we're just trading pain with another mental state and discuss that, but it is the same question. I think, at least this is the question. I'm not making a definitive response to that. I'm just explaining what is the rationale behind this argument. Non-reducibility of the mental to physical, because mental states are shared by systems that structurally have very different mechanisms built into them.
Yeah, but it had been talked, like, for example, I read not long ago an article by Buzaki, and he talked about this, like this kind of how to say, things that definitions that come from psychology, for example, and they has nothing to. And he said that it's not really.
Fine. Okay. You have already answers in your pocket. That's fine.
No, but it's like it's not suitable. Like you talk about something you call pain, but it's not.
Okay, fine. Buzaki is right to have his own position, and I am. Yeah. But let's look at the flow of the arguments, and then when we conclude this topic, we can say we are happy.
Sorry.
Okay, I'm just raising the issue, and of course, almost everybody has an opinion about that. Buzaki may have, others may have, and so on. But that's the issue that is raised now. Okay, so again, I just want to make sure that you understand where the problem arises. The problem arises because, unlike physics, macro versus micro, at least in my view, multiple realizability is kind of looks more problematic potentially in mental, because it's believed to be shared, the same mental state, by systems which are very heterogeneous, and there is nothing really naturally in common as a mechanism. Okay. So just a moment, let me just finish this. So again, the argument, Hilary Putnam is not a dualist, okay? He is not saying mental states do not supervene on a neural state. So Putnam is committed to that relation, in the sense that at each time an animal or creature has pain, it is realized, it is instantiated by whatever physical mechanism. However, there is nothing, the different mechanism, there is nothing unite them, okay? So it's not that there is no mechanism, but every individual instantiation of pain has supervened on some physical mechanism. But this is my physical mechanism. Other animals may have different physical mechanisms and are likely to have, and so on and so forth. Yes, there was an issue question.
Why can't we generalize the notion of the multiple realizability to multiple models? Like if you take in physics, you can have pressure of maybe 1 atmosphere in fluids, or in ideal gas or fermion gas, and there are very different mechanisms to get this specific pressure, but we all agree that they all have the same pressure. Why isn't this the same? They all have the same pain, but with different mechanisms.
So the difference in my view is the following. If we understand but in a mature science, mature physics, that we understand the relation between microphysics and thermodynamics, for instance, on this basis, we can understand what is the microphysical mechanism that is shared among all systems that exhibit the same pressure. How do I know that? Simply, operationally, because I think we can make predictions. We can say, let's take a system which has some different microscopic structure, okay? And based on our understanding what it takes to have pressure, we can make predictions that this system, although we never saw it, we never measured anything about it, will also exhibit pressure and so on and so forth, okay? We know from physics that physics, based on the microphysics, was able to make predictions of phenomena that was never observed and sometimes never dreamt of. Black holes, neutron stars, and so on and so forth, okay? Just because understanding of the microscopic mechanism, so you can make predictions. Now, the question is the following. If I understand human brain and human mechanism underlying pain, will I be able to make prediction that a worm will exhibit pain? Well, if I'm able to make prediction like that, okay, then it means that you're right, that there is some common mechanism, okay? Some philosophers believe that it's impossible because robot, for instance, may also exhibit pain if you program it, if it has enough richness, enough complexity, and so on. But nothing in common in the robot's mechanism and human mechanism, or even C. elegans, and so on and so forth. So the question is, again, whether there is some relevant common aspect of the brain of these diverse animals or entities that we can say, because of that, they all exhibit pain, or there isn't. That's a question. It's an empirical question, maybe. Okay.
So the key issue is whether the mental state gives you prediction about the mechanism? Like
independent of, no. If it gives prediction about the mechanism, then it's not multiply realized. But the question is, can mental states be causal? Can we make prediction that mental state A generates mental state B and so on, independent of the mechanism?
But maybe the problem could be, as Elisheva said, that it's the way we use the term pain. It's like an umbrella.
Okay, I'm not against it, okay? But let's see what others think about it. Okay. So the one very popular response to that, okay? If mental is not simply reducible to physical, then what it is mental? How do we, what kind of creature is it? So one response, very popular, and I think to a large degree, we all, or most of us, subscribe to it, even if we don't say it, is that mental state should be thought of as functional description, not mechanistic description, but functional. So what is mental state? Mental state is something that already hinted at the beginning, is described in terms of its causal relation to sensory stimulation, to behavior, but also to other mental states. So for instance, what is pain? Pain is not a mechanism. It's not that there is some C fiber that generates pain or some nocio receptors that generate pain and so on. pain is a state that tends to be caused by bodily injury and to produce anxiety, etc., etc. Okay, so this is the diagram below. You have some stimuli, input. You have some dynamics of mental state. This is this arrow, mental state 1 goes to mental state 2 and so on. And then, so there is a causal chain within the mental realm. And then there is, of course, also actions or behavior. So that's a definition. So if you ask, what is pain? If it's not the mechanism, or if it's not reduced to a mechanism, what is pain? Pain is this functional role, okay? We can say computational, okay? You know, some input, output, and some intermediate internal state, hidden variables, or whatever you want to call it, we can formalize it, okay? And that's a very popular approach to what psychology, what cognitive states are. Many cognitive scientists, for instance, would say that for us, doesn't matter, the brain is black box. So what is cognitive science? Cognitive science is this. It is a description of the relation, the causal relation between input, between output, and among the mental dynamics of the internal states of the mind. Belief, desire, decisions, and so on and so forth. Okay, so that's a position. So once you functionalize cognition, the question is, you're not worried about mechanism. So how come a robot will have pain and I have pain? Because in both systems, there is the same state transition, the same input-output relation. In my case, it is my, I don't know, amygdala and so on. In the robot case, it's some electronics. Who cares? Okay. You can think about this as algorithmic, if you want, software. You know, mental pain is kind of described in kind of algorithmic terms. So it doesn't matter. An algorithm can be run on very different computers. Nobody, I think, among us in this audience will try to find what is common between all hardware computers that run the same algorithm. I think it does make sense. Or it's very hard. It's very hard to see that there is something common. We just design so that the algorithm will run on my iPhone or some huge other computer or some maybe computing machine when I move things around and so on and so forth. Okay, so that's the idea. There is no, it's more like, in some sense, like I said, mathematics is not something that I have some pressure to reduce it to anything. It is its own rules and its own justification of existence. So also the mental is kind of an abstract characterization of the causal relation between mental states and behavior and sensory stimulation and so on. That's the argument. Okay. So, okay, so here it is. So we have this kind of high-level functional description of what pain is. And similarly, you can say memory, right? You can describe it in terms of information processing, Shannon information, and so on. Who cares whether it is the channel, the communication channel of Shannon is some television antenna, or it is some neural processor in my brain? They're all memory systems. It's a very popular notion, at least those of us that think about computation and information processing in the brain. So, okay. So then it's not surprising that there are different, heterogeneously different neural realizers of the same kind of algorithm, whether it's memory, whether it's learning, whether it is pain or something else. That's a position. Okay, I'm not saying I hold it, but that's kind of natural, one natural trajectory of argument. Because there are so many different things that cause the same mental states, then mental state is something more abstract. Functionalization of the mental. All right. Okay, so I want to just show you what I think comes out of it, maybe naturally, of this position about the agenda of neuroscience. So on the left-hand side, I try to make my own paradigm. If I'm functionalist, how would I view what neuroscience is, what psychology is, and so on? So I would say there are 3 stages. The first stage is kind of psychology, a very intuitive behavioral definition of what pain is, or what I don't know, desire is, and stress is, and so on and so forth. Then there's kind of cognitive science, which analyzes it algorithmically and kind of elaborates on maybe predictions, okay, kind of information processing, maybe information theory, there is some noise, there is some channel capacity, whatever it is, kind of cognitive science, okay? And then there is neuroscience, which says, okay, these cognitive science laws or predictions or whatever are realized in my brain in these processes, so let's see if it indeed does it or not. This is kind of the way I see what we are doing in kind of cognitive science, computational neuroscience, and so on. It's somehow maybe analogous to the famous 3 level of David Marr, which I think I mentioned early on, or we mentioned early on on the right-hand side. However, it's different. So there are some similarity, but it's different. David Marr is the middle state, the middle level is different in the sense that the middle level is also computational. Whereas here it's not necessarily algorithmic, it's more, it can involve more of the real world aspect of whatever those states are. So anyway, but there is some relation here. Okay, rather than to say computational theory and algorithm and hardware, I would say psychology, cognitive science, and neuroscience. But there's maybe some relation to that. Kind of the functional approach. There are a lot of variation on that, but that's all right. Now, I think what many of you opposed to this argument is what I'd call local reducibility. And this is the idea that maybe there is maybe it's a whole thing about multiple realizability is really, maybe it really doesn't really apply. And maybe, as Elisheva said, maybe my pain or Shaked, or I don't know, somebody else said, my pain is not the same as the C. elegans pain, is not the same as mouse pain, and so on and so forth. So that's what I would call local reducibility. So it's a different picture. It says there are different types of pain, and each type of pain is indeed is instantiated by many systems that have common structure. For instance, maybe all mammals share the same pain or very similar pain, but they have also similar mechanisms, but maybe maybe other invertebrates or I don't know, vertebrates, maybe flies have different pain and they have different mechanisms and so on. Okay, so this is kind of the natural response that maybe just philosophers dream about this multiple realizability of pain or of memory or of desire and so on, but maybe it's not really. Okay, so that's a natural response. Yes?
Just a small clarification questions, 2 questions. One, does that mean that that we cannot talk about a similar, so me and the C. elegans or me or in the robot will not have the same pain?
Yeah, that's the so here is what I want to summarize the debate, and I want to actually summarize the response to Putnam and other functionalists, and by Jaegwon Kim and others that argue that whatever multiple realizability is, it cannot be used as an argument against reduction to the neural. Okay, and the reason is the reason is, let's look at the bottom part of it. The reason is the following. If there is, so there are two possibilities. I'm sorry, I'm losing my point. Oh, here it is. Okay, the argument is the following. If there are some causally meaningful statements about pain, let's say, which is shared about all creatures that exhibit pain, if this is the case, then there must be some common neural mechanisms. Okay, let's forget about pain. Let's talk about vision. Okay, let's suppose we say vision, perception, visual perception is about detection of objects by light. Okay, something like that. Now I can say, okay, so if this is the case, then all animals or all entities that have vision, they must have something that interacts with photons or with electromagnetic radiation in the visible spectrum. Okay, that's a prediction. But obviously, in that view, that prediction actually says something meaningful about all systems that realize vision. Right? It's not trivial. They say that if I have a system, whether it's artificial, engineered, or is natural, that has vision, that system must have a mechanism that interacts with electromagnetic radiation at a certain wavelength. Okay? So the argument is the following. Either you have such meaningful statements which are based on a shared mechanism, then it's not multiply realized. Then there is something common to all systems that exhibit that mental state, whether it's pain, whether it's vision, and so on and so forth. Or if you think that you can have a meaningful statement about pain, which are not reflecting something common in the different systems, then it's not meaningful scientifically. So the question about pain, as Elisheva said, maybe pain is a concept in the language, but it's not a scientific concept. Why? Because we cannot really make predictions of every entity that has pain beyond the definition, of course. I have a functional definition of pain, then of course, it's whatever logically comes out of it. But beyond that logical statement, I cannot make any scientific predictions about the pain if they are not really shared by any mechanisms underlying it. So the idea is that perhaps we should not take psychology too seriously without any criticisms or scrutiny. There may be some concepts in psychology which reflect some concepts in our language, which are very important for the language, for our thought, for our communication. We're not going to erase it from the dictionary. However, they're not really interesting as scientific objects. For instance, tables exist. Tables, we are not going to, nobody's going to deny that there is such a thing like a table, okay? However, is table a scientific concept? No, because there are so many different things that can serve functionally as a table. Beyond the fact that it is functions as a table, you cannot say something meaningful about it beyond that, okay? So maybe pain is also like that.
Haim, but what about the normative implications? Because if you can define pain, it can have unfortunate moral implications.
Moral implication, that's fine, but moral implications, again, may not be reducible to any, we'll come to moral next week, but maybe not reducible to anything scientific. We're not going to, maybe, you know, there are moral consequences. It's like we have language and we have many other things, but it doesn't really mean that those consequences are reducible to neural things. I mean, do you think that there is a moral consequence of pain in C. elegans? I don't know. You know, it's again the same, similar question about, you know, moral.
I not necessarily say that. I said, but I think
even if there are, that's important. That means that pain may be a very important concept. Pain as such, not pain in me and pain in you. Pain as a concept may be a very important concept morally, has moral significance at its universality, okay? But that doesn't necessarily mean that it is a scientific concept.
I'd like to ask something.
Yes.
First of all, sorry that only now I can join, and I heard a lot of the previous lectures, so very, very glad that you have this course. I find the equivalence that you make between pain and vision a bit problematic, because with vision you have a very strong external constraint. The world is the same, and every living creature eventually needs to perceive the same, about the same things. Now with pain, you have different bodies, very different realizations of the body, the organization, whatever.
Vision. Okay, vision is also, vision is shared among animals which have very different mechanisms of the eye. They don't even have retina. I disagree. It's not, I'm not talking about vision among us. Vision, you know, visual sensation is something which is, you know, can be shared by very different bodies. Not to say that, you know, the fly vision is different, but even more extreme cases, we still will say they have visual perception.
I understand what you're saying. I'm just wondering whether, well, maybe you can still have very different like microscopic realizations, but still have the same macroscopic description.
Well, so that's the issue. Okay. What about pain?
So I would say that my argument is that maybe pain, because there are very different realizations of the body of different creatures. So maybe there it makes more sense that the microscopic realization is.
What about hunger?
I don't feel confident.
Okay, it can be that there are, fine, it could be that there are, let me just turn on lights, sorry. It could be, when I say that some of the psychological concepts are, you know, may not be relevant or may not have significant scientific significance, I don't mean everything as a package deal. You may be right. Some of them yes, and some of them no. That's fine. I don't want to get into argument with the pain or hunger, but I agree with you. Some of them, what I'm saying is the following: multiple realizability, I want to summarize, is not by itself a good argument against reduction, because mental states may fall under two categories. One category is that they do reflect, when you make predictions about mental states, that I have this distress, I feel stress, and therefore I'm depressed or whatever, if those predictions are really meaningful and hold water, then there is some common mechanisms on all systems that show this law, this prediction. The fact that we can make prediction must be, remember, no downward causation, must be that there is some physical mechanism that is shared. That's one category, and therefore this category, if you think vision is like this, fine. This category are meaningful scientific constructs in cognitive science and reduced to cognitive neuroscience and so on and so forth. And then there may be other concepts which are useful and potentially also more consequent. I think this is that's a good comment, that they may be very important to us as human beings and have moral consequences, and we'll discuss what that means later on, but not as a scientific, they're like tables or, I don't know, pencils and so on, useful concepts for the everyday language, but not scientific, not part of natural sciences or sciences.
But Haim, can I, so I'm trying to push a bit harder to make sure I understand the claim. When you say that we cannot make good predictions, what types of predictions are they? Do they relate to neural mechanisms? Do they relate to behavior?
No. If we functionalize a mental state, okay, then basically it's more or less what is the definition of that state in terms of input-output relation. Okay. We can define whatever we want. Now the question is if it's interesting. It's interesting if we can, on the basis of this definition, on this functional characterization, make meaningful predictions which are beyond the definition, which are not simply logical outcome of the definition, okay, because that's not interesting.
So for example,
in other words, if we understand pain in terms of functional role, and we understand vision in terms of functional role, or we understand stress in terms of its functional, we have a whole set of functional descriptions of mental states, then maybe we can start to make all kinds of predictions about non-trivial predictions, how to alleviate stress and what stress will generate and so on and so forth.
And then your assumption is that it might, and then in this case, if I'm able to make meaningful predictions, then your claim is that there must be, these states must be reducible to a neuroscientific.
If there are really predictable statements about the mental, then although they may be realized by very different creatures, there must be something underlying common, like many things that have the same pressure or many things that show the same phase transition and so on. Okay.
But the question is, what is your definition for a common mechanism that prevents multiple realizability? So let me give you an example. For example, Amir Ahmedi's work, where he takes blind people and he teaches them to, via transduction, to see things based on frequencies. Or when you, let's say that I would replace, one day I will be able to invent an eye that works on silicon chips rather than neurons. Would that be, so according to some philosophers, that would be a multiple realization of vision.
Okay.
And then you would say, but so, and then you say, no, but there is still something common. So my question is, where do you draw the line? Where is, because you can say that each one of us is a multiple realization of vision. My vision, my visual system is somewhat different than yours. You see what I'm trying to ask?
There is no, so I want to emphasize, there is no question about the enormous multiple realizability in physical sciences, in biology, in chemistry. The question is whether this is an argument against the ability, against the claim that any meaningful laws and generalizations and predictions that we make will reflect ultimately common mechanisms on the physical level. That's the question. It's not an argument against multiple realizability. No, but vision, I don't want to get again into the details. I think Amir Ahmedi is not vision, because in my view, vision has to do with light, and a blind doesn't have light, so it has substitution of vision. So that's something else. But camera or a robot or an autonomous car may have vision.
Mm-hmm.
So, and there is some common mechanism. There is some common mechanism. There is some sensors that have the property of interact with light, as I said, at some spectrum, and that's meaningful. That's meaningful on the physical level. If you
definitely, but it just says what Hilary Putnam wanted to say.
What I'm saying, if you show me a blind person which does not have a functional elements, sensors that detect light, I would say it does not have vision.
Mm-hmm.
Okay. If you show me some black box and you tell me that black box has vision, I make a prediction that it must have a physical mechanism of interacting with light.
No, definitely. But I think what they would claim,
so
what Hilary Putnam was saying is that it's not identical to the mental states are not identical to the neural states, and this is why you have. So that what you're saying about the black box is an example of multiple realizability that would say that there is a reduction, but the reduction is not of an identity between mental states and physical states. I think
I do not want to get into the nitty-gritty philosophical detail.
Okay.
Different distinction between identity and reducibility. I am happy with reducibility. I don't know what identity is even in physics. The macro state of a solid or of a gas, of a liquid, or phase transition between this and that is identical to the micro state. It's not. So I don't know. Identity is beyond my philosophical resolution. I don't know what identical means. It's obviously you cannot say, a mental state is a mental state one is identical to a specific micro state one. I don't.
Yeah, it's obvious to us today, but when Smart made that claim in 1959, it wasn't obvious to him. So, and I think that's what Putnam is trying to fight. But yeah, okay. Thank you. I understood. Thanks.
I'm quoting Putnam, but I'm alluding to a whole school of thought that to this day argue about the non-reducibility of the mental to physical on the basis of a very heterogeneity of the neural mechanisms. So, and you can talk to, you can read Oron Shagrir and of our school and Orly Schenker of our school, and for them, functionalization of the mental is like dualism. I mean, this is a very strong position to this day, and I think that there are also very strong counter arguments against it. And to me, multiple realizability and reducibility is a matter of degree. This is why, that's what I try to hint in this kind of hierarchical structure. There are mental states which have, the details are only me. You don't have the same characterization of pair because of historical reasons and so on. But then there are some aspects which are shared. And then there are more aspects which are shared among more, all the primates and so on and so forth. All these, if they are meaningful generalizations, if there is something common between my pain and the mouse pain, there is common mechanism underlying. That's what I'm saying. So multiple realizability, if it is meaningful, if the concept is still meaningful, it means that there is a common mechanism underlying. Identity, I don't know what it means. I am interested in knowing whether, like chemistry or like biology, I can take mental states and think about underlying neural mechanisms, and is it meaningful or not? Okay? Is it something which captures that in principle, if we understand the microstructure of the relevant animals, we can build psychology. We can prove, or we can psychological predictions, not only in my brain. That's what I'm saying. If there is meaningful predictions made by psychology about a mental state as such, vision as such, then I can make these predictions without knowing anything about the neural mechanism, okay? That's the issue. And just because it has pain, or I think to the degree that we can do it, it means that there is some common mechanism. And if there isn't, then we cannot, then there are really no laws which are relevant to it. I think, well, anyway, at least this is what I think about. Identity relation, again, I don't know what it means. So we can argue about it. If you understand what identity means today, I don't know. I would be happy to discuss it. It seems to me so doesn't make sense to just take one-to-one mapping. It's not even in physics. In the most mundane systems, it's not one-to-one mapping.
I agree with you, but I think Orly thinks differently.
No, but to me, the question is whether the universality classes, which are defined by mental or by cognitive states, have something common into them mechanistically. This is the basic. I forget about pain, forget about philosophy. This, I think, the question. And I think it's a serious question because it's part of our research agenda, okay? We take a model, an artificial network, and we say, this is vision, okay? Does it share that the model, not because it's a model, but even if I could build it with hardware, that this model, do I commit to saying whether if it is a good model of vision, it means that there is some shared mechanism, or it's just a model. Functionally, it is algorithmically, it is like vision, but it doesn't say anything about the brain. So we are facing with this issue. This issue is not philosophical. Cognitive scientists say that, some of them say, we don't care about the brain, we just care about the algorithmic structure of the mind. And the question is it not really something which is reflected in underlying mechanism? You're not interested in it, that's fine. But anyway, so basically this is what I'm going to philosophy, but I want to go back to me, more important question. And this is, what is the conceptual framework of our field, cognitive computational science? And to me, my view is much more interactive in terms of those stages, that ultimately any laws of psychology or cognitive science, if they are serious, if they really make predictions, they must be derivable from neural mechanisms, okay? And therefore, there is a much stronger interaction between them. And this is why all these classical statements, whether David Marr or functionalists or others that say level 1, level 2, level 3, or scale 1, scale 2, scale 3, I think they are not really capturing what is really the way science in these fields are done today. They're really cross level. There is no clear distinction between cognitive and neuroscience. And I think that characterizes biology in general. Biology in general is not like physics. You can say there is thermodynamics and there is statistical mechanics and there is atomic physics and then there is quarks and so on, this separation of levels. I think it is true also in neuroscience to some degree. I mean, I'm not suggesting to study quarks for neuroscience or for cognitive science, but the levels between cognitive theorizing, computational theorizing, and neuroscience mechanism, those levels are really mixed up. And the same in biology. You talk about diseases, you talk about traits, you talk about molecular genetics and talk about evolution, and all these are very different scales and levels, and they are mixed up. I think this is what biology is. And I think it's an interesting topic to discuss, to separate, not, you don't have time in this course, about biology as a science in general, okay? There are serious, interesting issues there also in general, not only neuroscience and cognitive science, is that this separation of levels don't really hold much weight, much significance in modern biology and modern neuroscience. And therefore, it is more messy, right? It's messier in terms of the conceptual, because we mix in the same model, in the same paper, in the same scientific research, we will mix statements about behavior, statements about models, statement about genetics, evolution, and so on and so forth. That's what reflects our contemporary research.
You're basically saying that you cannot make predictions with a model that uses only, that is only in the cognitive level?
Well, no, you can make predictions, but I think those predictions, if they are real, if they turn out to be right, correct predictions, they reflect an underlying mechanism. You cannot make predictions, I believe, which are independent or not interesting predictions. You can make logical predictions. Vision is about vision and so on and so forth. But I think, anyway, I may be wrong, okay? But
I think that that's an interesting question by itself, when you can make those predictions.
Okay, I may be wrong about that. That's fine. As I said, I'm not 100% sure about that. You know, people argue about it. This is the argument. I think what you said now, this is basically the argument. Is there interesting science which is in principle independent of the mechanism? I'm not saying that you cannot make predictions, but the question is, the predictions that you make maybe just reflect the underlying mechanisms, but can you make predictions which are independent of what mechanism is behind it? In other words, that they will be correct independent of the mechanism. Yeah, that's the question. Whether you make predictions about the relevant system. I don't know. As I said, functional computational approaches are very popular today. And to some, they mean that you can do science about cognitive systems independent of mechanisms, and others are not so sure about that. All right. Okay. The final point, which we will make after the break, is about, I think somebody mentioned it already, a different aspect, not causal, not mental causation, not about functionalization, but about the experiential aspect of the mental. So some would say mental is not reduced to physical, because there is some experiential aspect, which is a very different beast than neural processes. Let's take a break, let's take coffee, let's experience some relaxation, and come back to debate about that. All right. Topic is the experiential part. And basically for some, for many, the mental, whether we said pain or fear or stress and so on, for them, it's all about conscious pain or conscious feeling of pain or conscious experiencing of hunger and so on and so forth. Okay, and therefore the question is really, what can we say about consciousness, assuming that this is an important part of what we mean by mental states. Okay, so it's well known I'm sure all of you heard about the two problems of consciousness. So again, consciousness and conscious experience, okay? The conscious aspect of perception, of decision, of desire, and so on and so forth. So you all know that there are two problems of consciousness, the easy part, the easy problem and the hard problem. I must say that often when I hear lectures about consciousness and I hear, this is the hard part of consciousness, I see confusion. People, even scientists or professionals in psychiatry and psychology, call the hard problem of consciousness not what I think is really the hard problem of consciousness. So I want just to briefly go over the distinction between the easy part and hard part. Is an ancient distinction, but I think David Chalmers has popularized that distinction about a decade ago in his article, The Problems of Consciousness. And let's see what it is about. The easy problem of consciousness include the ability to discriminate, categorize, and react to environmental stimuli, the integration of information by cognitive system, the reportability of mental state, the ability to report about it, the ability of system to access its own internal state, focus of attention, control, wakefulness and sleep, and so on and so forth. So these are examples, instances of what is known as what is defined as the easy part of the easy problem of consciousness. Now, what is the hard problem? The hard problem is the problem for experience. So example, when we think and perceive, there is a weir of information processing. It is information processing, but there is also subjective aspect. When we see, for instance, we experience visual sensation, the felt quality of redness, the felt quality of emotion, the experience of a stream of conscious thought. Okay, so there is experiential aspect, there is a subjective, a feeling, a quality. So all these are ingredients in the hard problem of consciousness. And now the question is, are these one problem or many problems? And the last sentence is also important. What unites all of these mental states is that there is something it is like to be in them. There is a feeling of to be in, to experience this, to experience that, and so on. This is the subjective feeling of participating in that. And that's all conscious states have that aspect. This is actually, it is like to be, it is actually paraphrasing Thomas Nagel in 1974, what is it like to be a bat? To be, that's the puzzle. Can you imagine what it is like to be a bat? All right. So again, I won't read everything, but you see the last sentence of Thomas Nagel. I do not deny that conscious mental states and events, mental events, cause behavior, nor that they may be given functional characterization. I deny only that this kind of thing, namely causal and functional characterization, exhausts their analysis. In other words, he said, yes, consciousness has causal relations with other things and has functional characterization, but it is something above and beyond that. Okay, so if I go back to Chalmers' easy and hard problems, to the right-hand side, I bring some examples. Very famous research agenda, neural correlates of consciousness, started by Christoph Koch and Francis Crick, maybe 15 or 20 years ago. So this is kind of the causal reduction of consciousness to neural. There is another popular line of thought about consciousness, information-wise or dynamic. Tononi and others developed the integrated information theory IIT of consciousness, very popular and influential. You can think about it as functionalization of consciousness. So you can see that consciousness has reductive aspect to causal neural processes. It can be maybe functionally characterized as some information processing system or mechanism. However, neither of these capture the subjective feeling of consciousness. So this is the hard problem, okay? So I want to emphasize the hard problem, in my view, by definition, has no functional role, because if we can functionalize it, it is not subjective. It is part of a causal structure, whatever there is an internal feeling or not, hypothetically, and no mechanistic account. That's what Thomas Nagel and Chalmers say, and no external accessibility. I think that last part is important. The hard problem of consciousness is something that you cannot measure. Somebody can tell you, I can tell you how I feel, but you cannot access this feeling independently. Okay, you cannot look at my neural pattern and say, this is the way redness is felt by this guy. Okay, that's the it's sometimes called qualia. Qualia is the qualitative first-person subjective feel of my subjective internal feeling. Okay.
This is an assumption.
In my view, I just finished. To my view, this means that you cannot really look at MRI, you cannot look at EEG and get direct access to this subjective feeling. Yes, there was a question here.
I'm just asking, this is an assumption?
Okay, it's a good question. This is an assumption. It's a good question. Is this an assumption? Is it an empirical fact? Is it an assumption? Or it is a statement that it's obvious? That's a good question. What do you think?
Well, I'm asking this question after reading a book by Michael Graziano, and I really liked his approach to this.
Who is talking?
Hadar, sorry.
Okay, can you turn on your video?
Yeah, sorry.
Thank you.
So Michael Graziano, who was there in the consciousness conference where you also gave a lecture there, and also Liad. And I really like his approach. He's basically saying that this qualia, he says that his approach saying that this is the conscious being is actually modeling its own state. So he doesn't use these kind of terms of qualia and this like a magic. It says that it's just the person, the animal modeling its own state, and this is what it is, and it can be. And he believes that it can be measured. It can be. We can find this realization, but this is one opinion.
So there are many arguments back and forth. There is a famous argument about, I think, about the neuroscientist that was raised in a dark room that never experienced vision. However, she studied all that science can be said about vision. She knows the photoreceptors, and she knows all brain activity that are generating visual experience anything that can be said about vision, she knows. Now, one day she opens the door, or the door is opened, and she gets out of the room, and all of a sudden she has a visual experience. So the question is, is something new happened to her? Did she gain any knowledge? Is it, or just the same? She already knows what vision is. She already make predictions how she'll react to visual experience because she knows everything. So
She has a new state
it's
to have.
somewhat different. It's a different line of thinking, but it's similar to whether the first-hand experience is something which is there above and beyond the causal, the functional aspect of that experience. That's
So this approach doesn't.
That's finished. The other, just throwing in other things. For instance, the question of zombie. Is it possible that we will have around us zombies, which are creatures that behave like us, they have the same neural systems and so on, but they don't have this subjective experience? Can we tell? That's the question. Is it real or not? Can it be that we will have, I don't know, maybe you don't have, you don't have subject. I think you have, but how do you know? In other words, that's the question. Is it real or not? Is there something there or not? I don't know. What do you think? Liat, do you have an opinion about that?
About whether Mary will learn something new or not?
Yeah, is there something which is there something in our experience which is not accessible to kind of objective experimentation? In other words, that I can meet on the street in principle somebody that looks like human being, that behaves like human being, but it's empty inside. It's void. It's just zombie. Is it possible?
So, in my opinion, and it's just my opinion.
Yeah.
Philosophically speaking, I don't think there is any way to differentiate between such a zombie and ourselves. This is the problem of the other minds. And I cannot know that you have consciousness, but I do think for sure, but I do think they have a good enough justification to assume that you do.
Okay.
So I would say it's possible that you don't, but it's highly, highly unlikely.
But it's possible. In other words, it is possible, but it's unlikely because I agree with you, because
we have the same, similar, it behaves like we have similar neural system.
But it's possible.
Yeah, and now you're asking me to extrapolate from that on the ability to study consciousness scientifically. And I don't know, like you're to ask whether there is an aspect of consciousness that will never be explained, as David Chalmers.
Not because of practical limitation, but kind of in principle, theoretical limitation.
Yes. So I don't know if everyone here. So there is a nice story that I like. So 23 years ago, Christoph Koch and David Chalmers had an open debate, and they made a bet. Christoph said that within 25 years we will solve the hard problem, and David Chalmers obviously said the opposite. And I think it's on some dinner or a bottle of wine. So 2 years from now, clearly Christoph will be wrong because we haven't solved the hard problem, and I don't think we will solve it in 2 years. When I study consciousness, I study it with modesty. I try to study it with modesty. I acknowledge the hardness of the hard problem. I don't assume that I or any other scientist will be able to solve it, but I do think that we can make a lot of progress in understanding the related mechanisms. And what I really like, one of the sentences I really like from Thomas Nagel's What It Is Like to Be a Bat paper, is that he writes there, I cannot conceive of a way by which consciousness will ever be reduced, scientifically reduced, but I may be like a pre-Socratic philosopher in ancient Greece that doesn't understand how matter will ever turn into energy. So it could be, I think it could be that one day there will be some major breakthrough that would change the way we think about science, about physics, about consciousness, like Einstein did for physics, or like quantum mechanics did for physics. And then the hard problem might be solved. Currently, I'm not sure it's something that without such a breakthrough, I don't think that's something we can do, but I do think that there is a lot of merit in studying towards that. So in advancing our understanding of the problem and of related mechanisms. So I hope I answered your question.
Yes, I think I like the quote from Christoph Koch, in 25 years we will solve, I mean science, will solve the hard problem. I don't even know what it means, because according to my definition of the hard problem, it's not accessible to science. So it's not a matter of 25 or 50 years, because if you can maybe that's what Christoph Koch meant, you can perhaps understand the neural correlates or the neural mechanisms that give rise to such subjective feelings and so on. But that's not,
just to
that's
say
the easy problem, not the hard problem.
You mentioned IIT before, and if you ask Tononi and Christoph with it, IIT does aspire to solve the hard problem, not only the easy problem.
So I must confess, I don't know what, I think they don't understand what the hard problem is, because the IIT is I don't know. The IIT may be just, again, a characterization of what systems or what are the necessary conditions for a system to exhibit consciousness, or maybe IIT says every system that it's complex enough that information cannot be divided has conscious experience or maps of possible conscious experiences. But again, it's not
the topic of it's a fascinating question, and I'm happy to discuss it later on, but it will take us at least a semester.
I know. I just want to finish today this aspect.
I just wanted to I maybe also don't understand the hardness of the hard problem, because let's assume I'm conscious because I'm thinking and my own experience, I am conscious. If I would clone myself molecule by molecule and would have a second myself next to me, and with exact mechanistic, the same atoms in the same place, I have to assume the second being, which is a physical clone of me, has also consciousness, right?
Yes, but the hard problem would be, why do some neural processes are accompanied by...
Okay, but let's go a step further. So, okay, if you on that the molecular cloned me is conscious, yes. So let's simulate the molecular cloned me in a computer. Yeah. Okay, very nice. So now me inside MATLAB, I'm also conscious. Right?
Okay. So I'm fine. You're making a bold statement.
No, but I'm trying to challenge. Like if you agreed with the first one, why is the second one so much different?
Yeah, it's I'm afraid that in the 4 minutes we have, I won't be able to give you a good enough answer. But for IIT, definitely the answer is no, because it relates to the physical conditions of the system and it cannot be simulated. But in any case, even if you do that, that won't solve the hard problem of consciousness. The hard problem of consciousness is to explain how and why specific neural or whatever mechanisms give rise to consciousness.
I agree.
Why would that happen? That's the big question.
I agree with that. We can, for the same reasons that I have with high degree of confidence, I believe that you and all of you have conscious qualitative experience, somewhat similar to mine. For the same reason, it might be that I could also extrapolate to some intelligent other beings. I don't know, we can argue back and forth. But I think what Thomas Nagel and Chalmers are saying, that there is no obvious scientific way to explain what it does, why it is there. What is this? It's something which is so different from anything else that science is dealing with, that which is objective and accessible and so on, that it's not clear why we have experience rather than not having experience. You can say, well, it helps us doing this and that, but that's the causal aspect, that's the behavioral aspect. Anyway, I'm happy to discuss this offline. I just wanted to say, in my view, my humble view, is that there are two options. Either qualia is not real. As somebody mentioned, it's we think there's some subjective experience that isn't, or it is real but outside scientific inquiry because we don't have, by definition, we don't have access to it. I don't know. It's I'm willing to discuss either way. I'm not against the idea that some aspects of our reality, particularly our internal inner experience, are outside what science can help us with, or maybe I'm wrong. I just want to, before we continue, I'm happy to stay and argue, but I just want to summarize the mental physical relation. There are three main aspects to me, in my view. One is the reductive causal aspect, which I think, whatever multiple realizability are there or not, is the ability to reduce laws corresponding to the mental to underlying neural mechanism, kind of causal reductive aspect. There are some functional aspects which may be defined in terms of kind of algorithmic and the computational terms, and the relation to mechanisms maybe are debated, but still they are well defined, mathematically expressed, and objectively scrutinized functional aspect to the mental states. And the third aspect is the qualitative aspect, the experiential aspect, which we, in my view, have a lot to say about our experiences, but it's not clear how it interacts with scientific inquiry. That's a summary of what I think we can say about the major aspect of mental to physical relation. Causal, neural, functional, algorithmic, and qualitative, subjective. Okay, next week, free will and consequences of free will, moral responsibility, and other potential consequences of the notion of free will. Okay, let's stop here.